Hello everyone, welcome to my channel Chemical Engineering Education. Today I am going to calculate friction factor using Colebrook-White equation. Here is the problem statement. You need to determine the Darcy friction factor F for turbulent flow in commercial steel pipe carrying water. Here are given datas. Reynolds number RE 1 into 10 to the power 5. So that means this confirms turbulent flow. Absolute roughness epsilon, that is 0.045 millimeter. Pipe diameter D, that is 100 millimeter, 0.1 meter. So here is my objective. Find the value of friction factor F that satisfy the Colebrook-White equation. The Colebrook-White equation is given below. So this equation empirically relates the friction factor to the Reynolds number and the relative roughness. So 1 by square root of F is equal to minus 2 log base 10 inside bracket epsilon by D by 3.7 plus 2.51 Re into square root of F. So from this equation you have to find out the friction factor F. So I'll solve this problem using Colesic as well as Excel solver. So this Colebrook-White equation is a nonlinear equation. So I am going to solve first by using Colesic. So here Re is 150, that is Reynolds number. Epsilon in mm, so that is 0.045, so that is absolute roughness in mm. D in mm, so that is 100 mm pipe diameter. And now I'm going to calculate epsilon divided by D, so that is equal epsilon divided by D. So that is relative roughness 0.00045. Now here I am taking the gauge value of F. So I can take a very small value 0.001. Then I have to calculate LHS of the Colebrook equation. So that is 1 by root F. So that I am going to calculate. So here I am calculate 1 by square root F. So 1 divided by SQRT then of root F. Root F means here the gauge value. Then RHS Colebrook, so that is minus 2 log base 10. I have to take that whole thing. So that is the right hand side. So that is equal to minus 2. Okay. So here I have to first do that. So equal minus 2 into log base 10. Then I have to take epsilon by D, already calculated here. Epsilon by D divided by 3.7 and plus 2.51 divided by, now I am taking one bracket. So here I have to put Re is 150 into then SQRT of F. So that is of F here. Then bracket close, another bracket close. So now enter. I'm getting that RHS Colebrook. Now objective function means I'm going to solve this. So LHS minus RHS. So that will be my objective function, and I'm going to make 0 by changing the F. Actually Colesic will do that things and give the actual F where this equation will be satisfied. So that will be the that A particular F where the equation becomes satisfied. So that will be our friction factor. Now here objective function will be LHS minus RHS. So now here you have to do that. So I did. So LHS minus RHS. So that enter. Now if I have to use Colesic. So for that data, then I have to go what if analysis Colesic. Now here set cell is this. So that is 0 by changing this cell F. So now okay. So now you can see here. So now that difference between LHS and RHS, that will be set cell. So target is 0. So you can see that current value is 1.09527 E, minus 0.5. So that is almost 0, and our f gas now changed it to 0.02012. So that is the friction factor. So from here we got friction factor 0.020120248. Now I am going to solve the same problem using Excel solver. For that I have to take again gas value. Suppose I am taking 0.001. Then I have to calculate LHS. LHS is nothing but 1 by SQRT of F. F is here. Then I have to calculate RHS, that is equal to minus 2 into log 10. Then I have to take epsilon by D. So epsilon by D is here, divided by 3.7, then plus 2.51 divided by, then first bracket, then RE is here, into, then square root of F, SQRT. So here SQRT of F is already here, that is the gas value. Then bracket close, another bracket close. So now enter. Now here friends, so that is equal to LHS minus RHS. So you'll get that. Now here I'll use Excel solver. So for that you have to go data, then solver. So now here you have to set this cell is equal to 0 by changing this F cell. So this gas value, this one. Now here is the constant. So I can put that F gas greater than 0. So that I'm deleting that. So add this F greater than equal to something. I'm taking that small value. Okay. So now I'm using, that is GRG solver, GRG nonlinear solver. Now if I solve, I hope I'll get solution. So I'm keeping the answer. So now I'm getting the answer, that f value is 0.201. So this value is our answer, that friction factor. So this is the friction factor, and by using Excel solver, and I'm getting friction factor by using Goal 6. That's it. Thank you.